Newton's first law of motion.
Newton's first law of motion states that an object in motion stays in motion as long as the net force acting on the object is zero. If an unbalanced force acts on an object at rest, it will move at the same speed and direction until another unbalanced force acts upon it. On Earth, however, friction causes objects in motion to slow down and stop. Newton's first law of motion is also referred to as the law of inertia. Inertia is an object's tendency to resist change in motion. In other words, an object that has a greater mass has a greater inertia, causing it to resist change in motion. However, a smaller object with a smaller mass has a smaller inertia.
When the water bottle is at rest, it has a net force of zero. It will stay with a net force of zero until an unbalanced force, like Elaina's hand, acts upon it. Once Elaina's hand acts upon the water bottle, it gains a net force greater than zero. Example 2. When a book is sitting on a table, it will stay motionless on the table unless an unbalanced force acts on it and changes its motion.
Newton's second law of motion.
Newton's second law of motion states that the acceleration of an object is equal to the net force acting on it divided by the object's mass. The mass of an object is a measure of the inertia of an object and depends on the amount of matter in the object. If you double the mass of an object, it cuts the acceleration in half. The formula that Newton created is net force divided by mass equals the acceleration. The acceleration of an object is always in the same direction as the net force.
Example 1. Two people have different sizes of wood with different masses. This piece of wood has a greater mass than this piece of wood. Greater mass requires a greater force. Second example. Nicole will push the scooter. Now she will push it with Francesca on the scooter. Don't make me fall. Newton's third law of motion.
Newton's third law of motion states that for every action there is an equal and opposite reaction. This means that every force that is applied to an object, the reaction will have the same and equal force being applied in the opposite direction. If there is a great amount of force applied to an object, the reaction will have the same amount of force in the opposite direction. All forces come in pairs because for every action there is a reaction.
First example, if two people are running towards each other at 10 miles per hour, they will both fall back at 10 miles per hour in opposite directions. Okay. Second example, if you exert force on a table with your hand, the same force will be exerted on your hand from the table. The first time Elaina hit the table, she did not hurt her hand. Because she did not exert a hard force. The second time Elaina hit the table, she hurt her hand because she exerted a harder force on the table. Therefore, she felt an equally hard force on her hand.
You've been speaking to Mommy.
But in opposite directions. Wait, no, we messed up. Example 1. Two people have two different